We have a very serious problem here. You can see this phone showing that it's charging with no current consumption when you take a look at the ammeter. So I received this phone from another phone technician, and this problem is quite common, and a lot of technicians are finding it difficult to solve this problem. I'm checking the battery because the technician said he changed the battery, then yeah, started getting this problem, right? So I'm just opening the battery to check something to see if it's a manufacturer error or something. I'm taking a look at the pull up and the pull down kilo resistors. We have these two resistors. You can see one connected to the ground, the other one connected to the voltage side. So the one connected to the ground is the pull down resistor, the one connected to the voltage side is the pull up. So I'm looking for 8 kilo ohm to 10 kilo ohm right here, because if these resistors are not reading, giving this reading, it might be like, yeah, the problem is actually from here, even though it's still a new battery, right? So I just wanted to confirm that before I go on to the phone to start troubleshooting. So everything was okay, the reading was okay. I just put the battery intact and I went on to work on the PCB just like that, and very smooth. So I'm pulling out the parts of the mobile PCB, and I checked the schematic diagram, and the schematic diagram of this mobile phone was not available. So it was very hard for me to troubleshoot and fix this fault, but I will tell you exactly how everything went. So taking a look at this little circuit right here, this is the charging circuit. We have the battery connector right here. We have a very small charging IC. So because I never had the schematic diagram to do proper and deep troubleshooting, all I was looking for the charge LDO voltage and the charging voltage. So I was getting a 4.1 volt in the battery connector, which means that the voltage is enough, but what was missing was the current, and I had to confirm if the charge LDO is okay. We will talk about the LDO clearly. I want to focus right now so that we will talk about the charge LDO, because this is a very important part in the charging circuit. So why should we talk about this part, even though it has nothing to do with the voltage that is charging the battery or the current that is charging the battery in this case? So the charge LDO is referred as low dropout regulator. So this charge LDO, if you are looking at schematic diagrams, in which I don't have a schematic diagram of this particular PCB, if not I will just display and show you what I'm talking about. But if you are working on a different PCB, the charge LDO, you will see CHR, and you will see LDO, or you will see CHR, and you will see REG in a schematic diagram. Yeah, depending on a mobile PCB, you will see two of these. So in this particular PCB, I think it should be CHR and LDO. So what is this line? And like I said, it doesn't have anything to do with the charging voltage or the charging current. So why should we focus on this? So this is a very important part in the charging circuit. It helps depending on the PCB. Keep this in mind. So if you take a look at the PCB that you are working on, this PCB uses a small charging circuit, a very small IC, right? So in mobile phones like this one, the charge LDO is not being generated from this charging IC because it's a small charging IC. But when we talk about PCBs with a big charging IC, the charge LDO is generated by that IC. This charge LDO that I'm talking about is a 1.8 volt, a 2.8 volt, or a 3.8 volt, depending on the mobile PCB, which means that different PCBs will differ, will have different voltages, either 1.8 volt, 2.8 volt, or 3.8 volt. So what is the function of this voltage? The function of this voltage is to power up some sections inside the PMU IC. For example, the function of this line is that it helps your PC detect your phone when you connect a USB cable. So that's a very important part when it comes to the charging circuit, the USB lines in a mobile PCB. The voltage that the LDO sends into the power manager IC enables the USB logic section in the power manager IC so that your phone can be able to detect on your PC when you connect it through a USB port which means that if the LDO voltage is not available, your PC won't be able to detect your phone. That's why in some cases, when you are trying for a phone to detect on PC, even after changing the charging port, everything is clear, still doesn't work. Even when you change the charging IC, maybe the LDO voltage is missing. And also, this line acts as a communication line, especially in small charging circuit. These communication lines can be I2C boards or SPI boards, depending on the mobile PCB that you are working on. You see how important this line is. This is the reason why I first checked, even though without the schematic diagram. This is the reason why I first try to identify the section, test the resistor if it's getting the V-bus and giving out the LDO voltage, in which I got 2.8 volt, and that's okay. So let's see what we can do to solve this problem from here. So after checking with the 4.1 volt and the 2.8 volt from the LDO, I had to replace the charging IC. That was all that I could do because no schematic diagram. I could not do proper troubleshooting. So yeah, it was very simple. The circuit wasn't that complicated to figure out. I just checked on what I was checking and I noticed that the problem should be lack of current. So I removed the IC. As you can see, I removed the IC and I had to replace with the same one from the same PCB. You check on the number written on the IC just like that, and very smooth. Well, you can get my courses right now with a 50% discount. That's going to expire soon. The discount is going to expire soon, so I think you should rush now and get the courses before it expires. And yeah, just like that, I replaced the IC and everything is good. Everything looks clear right here. So it's time to test the mobile PCB, see how everything goes. I connected the phone. Let's take a look. That's 1%, right? So after some time, we see 8%. As you can see, we have a current consumption from our ammeter, which means everything is okay.